All right, where we left off, we finished number 5. We're going to take a look at the next number 6, which is a multiple choice question. We have a likelihood that someone, a randomly chosen American, is a registered Republican. We're going to take a sample of 10 Americans. What's the probability that at least one will be a Republican? Once again, does not state that it is binomial, but it is because we have a certain number of trials, probability of finding in this case, somebody with the registered Republican Party, and then I'm calculating a specific probability with it. So binomial, 10 trials, 0.35 chance of success. Probability that is greater than or equal to 1, which is the translation of at least 1. Since it's greater than, it'd be 1 minus. I'm going to subtract everything below that. So if it was greater than or equal to 5, I would do 1 minus the CDF of 4, because that would give me 5 and higher. In this case, the only thing that's below 1 would be 0. So really you could use either the CDF or the PDF here, but just to stay consistent with what we did that chapter, I used the CDF and got A as my answer. Okay, starting with number 7, you have entering chapter 7, so the sampling distributions. For the sampling distributions, what you want to read very carefully for is whether you're just looking at one of something or if you're doing a sample of more than one and looking at an average. So for 7A, we're looking at just one truck, so the probability that it will hold over 800 pounds of dirt, since we are told it is a normal distribution, is just 800 and higher with a mean of 750 and a deviation of 40. Okay, fairly straightforward. Just as a reminder, here are the formulas from directly from the formula sheet for sampling distributions of sample means that'll apply starting with part B. So notice very similar wording, but now I'm looking at a random sample of 5 trucks, and I'm looking for the average, whether the average be 800 or more. So everything else in my normal CDF is the same, except for the deviation is now the old deviation over the square root of the sample size. And notice that it's a much smaller probability that I would get an average of over 800 than if I just was looking for the probability that I would get a single truck over 800 pounds. Okay, same thing, number 8. Let's compare these. So part A is talking about what's the probability that just one randomly selected woman is over 66 inches. B is how likely is it that a sample of 4 will have a sample average greater than 66. And then C is the random sample of 100. So once again, notice all 3 of these, same lower and upper bounds, same mean. The deviation is all that's changing. So deviation of just 1 is straight deviation. Deviation of sample size of 4, and then sample size of 100. And as the sample size gets smaller, the deviation is going to get smaller as well, which means that 66 gets more and more unlikely, so you get very, very small probabilities, and you even sometimes have the possibility of getting a 0 in your calculator if it's so terribly small. And this one, I'm surprised it didn't give me a 0, but gave me scientific notation instead. Okay. Number 9, if I have number of eggs that a housefly lays, we know is skewed right with a mean of 800, a deviation of 100, so I can still find the mean and the deviation if something is skewed. What would this distribution of samples look like? So a smallish sample, like 16, would still be skewed to the right. It would be less skewed than the population, but it would still be skewed. Remember, 30 is kind of our line in the sand that we draw. So anything under 30 would be skewed in the same direction as the population. It would have a mean of 800, and I could still calculate the deviation here. But with both B and C, I have a sample size larger than 30. 30 or larger, you would say, is approximately normal. It doesn't change how I calculate the mean, which is the same as the original, or the deviation, which just follows the formula I had up at the top of the page. Main thing with this difference in the sample size is between that and A is that I can now say it's approximately normal, and notice as the sample size gets larger, the standard deviation gets smaller. Okay. For number 10, it goes back to that housefly example. I would not be able to calculate any probabilities with it because for part A, because the distribution was not normal. So if the distribution is not normal, I can calculate mean and deviation, but I cannot calculate a probability. With both B and C, it's fine though. I can use normal CDF because the sample sizes are large enough, just with 750 or higher to positive infinity, with the mean and the deviation that I had calculated previously in number 9. Okay. Likewise, in number 11, I now have the percentile, which hopefully from the previous problems, remember percentile means I'm going to use inverse norm. I'm going to work backwards or work in the reverse. So I'm going to put 0.9 here with a mean of 800 and a deviation based on the sample size. Okay. Once again, I cannot calculate part A because of the fact that the distribution was not normal. It was still skewed right because of the small sample size. Okay. Number 12, here is one based on how small the standard deviation is, where I did get a 0 as part of my probability. So I know we've talked about that before. It's not likely. Sometimes it means you made an error. In this case, with sampling distributions, it just means that you have a very, very small deviation. So, for instance, 50,000 is far enough from 48,500 that the probability is essentially 0, not even worth the scientific notation. So with one tire, I would use just the deviation given with a sample of 100 tires. Now I'm talking about the average of 100 tires being less than 48,500. Very, very unlikely, okay, that the average for 100 tires would be that small if the average is supposed to be 50,000. Okay, part C, just a different way of asking what kind of happened in 9, 10, and 11. If I had been given the information in the beginning that the lifespans of tires were not normal. Okay, so we were saying normal, so we didn't have to worry about the one tire being too small of a sample. But if it was not normal, it would cause a problem in one of our calculations. So I could still calculate part B, even if the population was not normal, because the sample was 100. So anything 30 or higher, I could still calculate using normal CDF or using inverse norm if it had been worded a little differently, because the sample size is large enough, the sampling distribution will be approximately normal. However, I would not have been able to calculate part A because if the population distribution was not normal, I would not be able to use normal CDF to calculate the probability of less than 48,500 for one single tire. So it works with the sampling distributions of sample sizes 30 and higher, but not with anything less. I would not have been able to calculate the answer. Okay. The last one in this review packet is still sampling distributions, but with proportions instead. We had a little bit of confusion. This kind of sounds like binomial, how it's set up. So you still have a probability of success. You still have a certain number of trials. The difference is that the problems will be worded in terms of proportions or percents rather than raw numbers. So if it was a binomial, it would say, what's the probability that at least 63 people arrive on time? I could use binomial. If it's talking about more than 63%, though, the most efficient way to solve it would be with the sampling distribution for proportions. So once again, here's the formula directly from the formula sheet. So the mean will be equal to the mean of the population, 78%. And then the deviation of the p-hats, the sample proportions, is equal to the root of p times 1 minus p over n. So more than 63% would be 63% or higher. Once again, realistic upper bound of just 1, representing 100% would be fine, with a mean of 78% and a deviation of 0.78 times 1 minus 0.78 all over my sample size of 100, and I get 0.9998. No more than 30%, okay, so I have 30% or lower with a mean of 0.78 and then the same deviation. And once again, it's such a small likelihood that I actually do get a 0 on my calculator. Last one, so I have 60% of workers who enroll in this course will pass the final exam. 28 workers were selected. What is the probability that somewhere between 70 and 80% of them will pass? So because it's worded in percentages or proportions, we would do normal CDF, 0.7 to 0.8 with a mean of 0.6, and then the deviation 0.6 times 1 minus 0.6 over 28 and under the root. And I get a 12.5%-ish likelihood that that would occur. Okay, so that has been a review of Chapter 2, Normal Distributions, Chapter 6, which is the random variables, the adding and the variances and the means, as well as the binomial and geometric is in that section as well. That'll show up on the homework. And then Chapter 7 is the sampling distributions. So if you have any trouble on any of those sections, please pull up back your tests or your notes from those sections and look over them. Tonight's homework is going to be a packet similar to this with quite a few. It's over half multiple choice and then some free response at the ends. And then we will talk about questions to this next class. The other thing I'm going to have you do between now and then, so when you finish the video, you're welcome to use class time to do this if you need a little break, or you can choose to start on the homework packet and do the review activity in a minute. There is a Stategories, a game I made up instead of Scattergories, where what I would like you to do is come up with as many vocab or other statistics related terms for each letter. And we'll grade it kind of like Scattergories. So if you say mean, for instance, for M, and other people have mean, we have to discount it. Only use words that you know the meanings of. If you are challenged on it, so if you say mean and you can't describe what mean is, then you won't get the full point. But it'll be kind of a fun way to review some vocab as we go the next couple of classes, and I'll see if I can come up with a fabulous prize for that. So 2 things to work on after you watch the video, either the Stategories if you want to do that first, or the packet over this material, and hopefully I will be back with you on Wednesday. Please email me if you have any questions either over this or any general questions about our AP test we're preparing for. See you soon.